Okay, so to start my video, okay, that's fine enough. So, in this video, I will talk about my major project, which is design and hardware installation of BLDC motor controller using TIC 2000 board, along with the edge bridge and all necessary equipments. So, I started this project last year in my minor project, which was a semester curriculum. So it was of three grades and it was named minor project. In the minor project, I did install the C2000 library and I worked here and there on the ADC as well as the PWM generation, EPWM generation part of the TIC 2000 board. And that was all I did in minor project. When I started my major project this year, so in that major project, I actually got the motor running. Although there are some problems, I think the problem might be in the power side only, the power supply and the edge bridge. But as far as my code goes, so it's working really fine in open loop. So I will just open my MATLAB and explain my program. So to run the BLDC motor, I ran using the Hall sensors. So I took the uh, output of Hall sensors. I got three output: H1, HP, and H3. H1, H2, H3, and I used a logic where to drive the MOSFET H bridge. I use six signals, which is G1, G2, G3, and then G4, G5, G6. 1 and 4 will be complementary. I think I found the solution to my problem. So, what I was doing, I think this might not be the solution, but I'll try this tomorrow. I will just try to swap 1 and 6, 4 and 6, 5 and 4, and these two. So, like the bottom three will get shifted by this, and then this one will come here. I will try this tomorrow. So, by doing this live stream, I think I found the solution, but I'm not really sure if that's the solution or not. So I will just if I was let me see if I have permission to share screen. Yes, I can. Entire screen. Yes. Yep, fine. So I can share my screen. Okay, so to start my video, and that was hello, hello. I've sent you a link. Check करो. Please do a like, share, and subscribe, guys. Like, share, and subscribe, guys. कितना समय लेगा यार ये जल्दी ओपन हो जाए. Okay, so जब तक ये ऑन होता है, I will just uh, explain the MATLAB side. So what I did in MATLAB was interfacing the TI board. Unlike okay, Arushi Prasad 488. Let's go. Okay, so yes. So in Simulink, what I did was I programmed the input and the output side. So for input, I took four input, three digital input from Hall, and then I had two outputs. I would no, there are three outputs. The not three, I would say six outputs. Six output. Three signals and three their complementary signals. I think I just found the solution to my problem by mm, describing my project only. Okay, so I think I can share my screen now. Okay, so this is my project. Yes. Hmm. A total of four blocks are there. The very first you can see here is called Hall effect. Next is called ADC for speed data. Then we have logic for computation, and then we have the actual EPW generation block. I'll start with the Hall effect. So this block does the very thing it says and it promised, which is taking three digital input, which are the three Hall inputs. Hall input one. Then I have Hall input two, and then I have Hall input three. Hall, Hall input three. HA, HB, HC. Okay. So the HA, HB, HC goes to this logic computation block. And here we have the computation logic for all G1, G2, G3. And you have your G4, G5, and G6. Then here you have the actually PWM block. So I used six channels in total. And why six, you may ask? I could have just used three channels and I would have got the complementary as well as the original PWM signal. So the reason for me to choose six was for debugging purposes. I don't know if I made sense by saying that, but टेक्नो हेक्सी टेक्सी क्या क्या ये टेक्नो हेक्सी पेक्सी मैसेज रिट्रैक्टेड हाउ डू यू रिट्रैक्ट अ मैसेज फॉर वॉचिंग भाई चार लोग कैसे देख रहे हैं हम इसको बंद कर रहे हैं